Okay, so this video is going to be on the limit definition of a derivative. For the first couple of examples, we're going to be using the limit definition to find and calculate derivatives. And for the last example, we're going to do a little practice AP problem. I just wanted to mention where, again, the limit definition comes from. And we could be talking about this point right here, x, f of x, and we're looking for a slope between that point and a point that is a little distance away. We're going to call that distance right here. I'm just going to say like that little distance is called h. So there's this other point up here. I should have made the distance a little bit smaller. Sorry, h is going to be here. And then this point will be x plus h and f of x plus h. So I'm talking about a slope between 2 points, and the goal is to make that slope and that distance between those 2 points. My goal is to basically just keep moving this point a little bit closer and a little bit closer until it's right on top of the other point, until h becomes 0. So we are limiting that h value until h becomes 0. So here's how the limit definition looks. It's the limit as h approaches 0, so we're trying to make that distance between the points nothing, of a slope equation. So our slope equation should be y2 minus y1, in our case f of x plus h minus f of x, over, and then our two x coordinates were x plus h minus x, which actually just becomes h. So the formula you'll see is that the limit as h goes to 0 of f of x plus h minus f of x all over h. And so that's going to be our limit definition of the derivative. There are some alternative forms. One of them is if you want to do a point form. So that point form could be the limit as x approaches a, and it becomes f of x minus f of a over x minus a. This also is a slope form, but in this one you should know what point you're calculating the slope at. And there is one more, but that other one doesn't appear very often, so I'm just not going to mention it. Okay, so in our first example, I'm going to be using the limit definition of the derivative to calculate the derivative of the following function. So the first thing I'm going to do is just find what f of x plus h will be. So I'm going to be plugging x plus h in, so I have 2 times x plus h plus 1 squared. Remember, when you say you're going to substitute x plus h, it means you're going to put that everywhere that there is currently an x. So f of x plus h is 2x plus 2h plus 1 squared. So I'm going to be expanding that. I'm also going to have to expand f of x. So I'm going to go ahead and expand both of these. So this one is going to be 4x squared plus 4x plus 1, and if you need to, you can actually go ahead and multiply it out. 2x plus 1 times 2x plus 1. For this second one, I'm actually going to go ahead and expand it. I'm going to multiply 2x plus 2h plus 1 times 2x plus 2h plus 1. So that's going to become 4x squared plus 4xh plus 2x. So that's if I multiply this piece times this piece, all right. And then plus 4xh plus 4h squared plus 2h. So that's multiplying this second term. And then the last piece, plus 2x plus 2h plus 1. So it's a lot of terms. I'm going to go ahead and combine some down just so they're condensed down a little bit. So this is going to be 4x squared plus 8xh plus 4x plus 4h squared plus 4h plus 1. So it's a pretty long piece, but we're going to be substituting that into our limit definition of the derivative. So now I'm going to set that up. So I have the limit as h goes to 0 of f of x plus h, so that piece in green is going to be substituted there, minus f of x, and the piece in purple will get substituted there, all over h. So this is going to be the limit as h goes to 0 of 4x squared plus 8xh plus 4x plus 4h squared plus 4. Ooh, sorry, this should be, oh, that's good. Okay, plus 4h plus 1. Minus, subtract this whole thing, and that one's going to be just 4x squared plus 4x plus 1. Sorry, I ran out of space, all over h. So when you subtract, a lot of your terms should cancel out. So these 4x squareds will cancel, the 4x will cancel, and the 1 will cancel. So we have 3 different pieces that cancel. So I'm going to go ahead and keep going with this. So this becomes the limit as h goes to 0 of 8xh plus 4h squared plus 4h all over h. So if I factor out an h, I'm going to have the limit as h goes to 0 of h times 8x plus 4h plus 4 all over h, and now the h's cancel, and so I can do the limit as h goes to 0. I can now substitute 0 where h is, so I'm going to take that 0, it's going to get plugged in right there, and we end up with 8x plus 4. Okay, so I'm going to do one more example. This one's using a square root function, so I'm just going to jump right in. This is the limit as h goes to 0, and in this case we're using g, so I'll do g of x plus h minus g of x all over h. So this is the limit as h goes to 0 of square root of x plus h minus square root of x all over h. And so we learned in the last unit on limits that the way to kind of manipulate this is to multiply by the conjugate. So I'm going to multiply the top and the bottom by square root of x plus h plus square root of x. So I have square root of x plus h minus square root of x times square root of x plus h plus square root of x over h times square root of x plus h plus square root of x. So in the numerator, this is a difference of squares, so it becomes x plus h minus x all over h times square root of x plus h plus square root of x. Oops, sorry, I should probably write the limit here. So the limit is h goes to 0. So that is now the limit as h goes to 0. And if you look at this problem, the two x's cancel each other out, and now the two h's would actually cancel, so it's going to be 1 over square root of x plus h plus square root of x. And because I can now substitute h as 0, it doesn't create issues, I will end up with that this is equal to 1 over, 1 over square root of x plus square root of x. The h now became 0 over here, and that ends up being 1 over 2 square root of x. Okay, so then the last piece is, on the AP test, they're not really going to ask you to use the limit definition of a derivative. They're going to ask you more how to interpret this problem. So if you looked at this problem, some key features you might want to look for is this piece right here. The limit as h goes to 0. And then there should be some sort of like f of x plus h. In this case, it's a point. And there should be a denominator here that's h. So I'm going to compare this to this other problem. The limit as h goes to 0, of f of x plus h minus f of x all over h. So if I looked at this problem, clearly the function that's in the top here is the function they are talking about. So in this case, it's going to be cosine. I'm not actually going to finish this problem out. We're going to learn about that a little bit later. But what I'm going to do is write this as a different notation. So this is asking me to take the derivative of this function right here. So the derivative of cosine, and you can replace the pi over 2 with x. It needs to be a cosine with a variable. And it's asking me to do this at, and I kind of write this like line here that says take this derivative and do it at this x value. So I want to know the derivative of cosine at pi over 2. I'm not going to get into what that is, but the whole goal of this problem is to interpret this to know that this says find the derivative of this function at this other point.